Hey everyone, today we're going to be working on the arriving at a certain height problem, and in this problem we're going to solve the two times that this ball here crosses the height of 22.9 meters. And so the variables that we're given to work with are the velocity, the initial velocity, the theta angle that the ball is kicked at, as well as the height we're trying to solve, which is 22.9, and the gravitational acceleration of 4.4 meters per second squared. So let's go ahead and check out our variables and get solving. So here I have them all written down and what we want to solve. And I have a couple diagrams here with what we're trying to solve, as well as the height and the ball's trajectory, as well as a little diagram with the initial velocity and the theta angle. And then I have a little picture of a clock over here to represent all of the hard work we're going to be doing today regarding time. So let's get started. The first thing that we want to solve before we go on to solving the time is going to be the velocity in the y direction. And if we all know that equation is velocity in the y equals the initial velocity times the sine of theta. And if we go ahead and plug in what we know and solve for what we don't, we know that the initial velocity is 16.5, and we're going to multiply that by the sine of 76.1. And if I plug that into my calculator, 16.5 times the sine of 76.1, we're going to get that the velocity in the y is equal to about 16 meters per second. And let's go ahead and box up this answer and move on to the next thing. So we're going to take this velocity in the y that we just calculated, and we're going to use the formula h equals v in the y times t plus 1/2 at squared to find both times here. And so once again, we're going to plug in what we know and solve for what we don't. The height is 22.9 meters. The velocity in the y is 16 times t plus 1/2 of the acceleration. And in this case, we're going to make the acceleration negative since it's a downward direction. And we're dealing with the velocities here. So we have to take into account that the gravity is going to be a negative value. And 1/2 of negative 4.4 is negative 2.2. So let me just erase this here, because this is going to be a minus sign. Negative 2.2 times t squared. And we're going to subtract the 22.9 meters from both sides, because we're ultimately setting up this equation so that we can solve with the quadratic formula. So the final general form is going to be 0 equals 2.2 times t squared plus 16 times t minus 22.9. And we're going to use the formula, the general form of the quadratic equation, which is t squared, or t, just t, equals negative b over 2 times a plus or minus the square root of the discriminant b squared minus 4ac, and that is going to be over 2a as well. And so you might be wondering, what are all these letters here? Well, let's classify each of our variables into their, or each of our numerical values into their corresponding variable. So the a value is going to be negative 2.2. The b value is going to be 16, and the c value is going to be negative 22.9. And we're going to fill it in here. T equals negative 16 divided by 2 times a, which is negative 4.4, plus or minus square root of 16 squared minus 4 times negative 2.2 times negative 22.9. divided by negative 4.4. And I already have the quadratic formula solved. So let me get these solutions here for t. So let's go ahead and enter 2.2. I have a little tool on my calculator that is a quadratic formula solver, so speeds things up a bit. Alright, so the two solutions, if you churn it out, you're going to get the same answer as I did here. So the first time is going to be 1.96 seconds, and the second time is going to be 5.31 seconds. And for the final answer, we have to convert these seconds into milliseconds once we put them into the website. And all we need to do that is multiply this value times 1,000. So the first t is going to be 1,960 milliseconds, and the second t is going to be 5,310 milliseconds. And there we go. So we're going to box these up. And now we have our times, so we're going to go ahead and plug them into the website and see how we did. So enter your name, and then enter the time while climbing, that's the T1, so 1960, and then the T2, which is 53:10. And let's see how we did. So the ball's going up. It's about to reach this first crossing here. 1954, looking pretty good so far. Reached its peak and it's coming back down. It's taking a little bit too. 53:26, so we're in the ballpark. And there we go. So our calculations ended up being correct, and hopefully yours are too. Feel free to email me any questions, and good luck with this example. Hopefully you can view the next one. Thanks.